All right, so now we're going to figure out the molecular weight given percent composition. And there are some rules that we need to follow. Just like we followed some rules in order to figure out the empirical formula, we're going to figure out some things, or we're going to do some things to figure out the molecular formula. Number one, if you're given percent composition and they ask you to do the molecular formula, the first thing you have to do is follow the steps we just did in the video before to find the empirical formula. Okay, once you've got the empirical formula, you add up all the masses of all the elements in that formula to get the empirical weight. Okay, good. Once you do that, you will find in the problem the molecular weight. It's always going to be given to you, the molecular weight or the formula weight. So that's basically the weight of the whole formula, the whole big molecule. So you're going to be given the molecular weight, formula weight in the problem. So what you're going to do is you're going to take that molecular weight that they've given you in the problem and divide it by your empirical weight. Okay, so this is always going to be bigger than this. This is always going to be a multiple of this. And when you do the division, you're going to get a whole number. That's your multiplication factor. So remember the example I gave you guys in the last video of glucose is C6H12O6, and its empirical formula is CH2O. So if I take the mass of glucose divided by the mass of the empirical formula, you get a multiplication factor of 6. So what are you supposed to do with that multiplication factor? You multiply the whole empirical formula by that number. Okay, so let me show you an example so that you know how to do this. The first part of the example is just a repeat of finding the empirical formula, which we just did in the previous video. Okay, so that should be easy enough. All right, so we are told that we have a compound that contains, here we go, 85.63% carbon, and it contains 14.37% hydrogen. Okay, so this is a hydrocarbon. All it contains is carbon and hydrogen. And when they did in another experiment, they figured out that its molecular weight, I promised you that you will always be given the molecular weight in the problem. They found that molecular weight is 56.1 grams per mole. So we could say molecular weight is 56.1 AMU, or molar mass is 56.1 grams per mole. Okay, so the question is, what is the molecular formula? What is the molecular formula? If I can spell molecular formula. All right, remember what the rules are. You first have to find the empirical formula. So let's follow what we did in the last video. We're going to assume 100 gram sample. So we have 85.63 grams of carbon, and we have 14.37 grams of hydrogen. We get the molar mass of carbon. 1 mole of carbon is 12 grams. 1 mole of hydrogen is 1.01 grams. Okay, and we do the math and we get 7.13 moles of carbon, and we get 14.2 moles of hydrogen. All right, so what did the rule say? We divide by the lowest number of moles. So we're going to divide this by 7.13, and we're going to divide this by 7.13. So you do the math, and if I'm doing this correctly, this will be a 1, and of course, and this will be a 2. So this is a 1, and this is a 2. Okay, good. So that means the empirical formula is CH2. But that's not the molecular formula. That's the empirical formula. All right, so how do I move on and figure out the molecular formula? You first have to figure out the the empirical weight. So we have a carbon and 2 hydrogens, so that's 14.0 grams. Great, so this is the empirical weight. Empirical weight. Good. So we need the multiplication factor. What did they tell us to do? They said take the molecular weight and divide it by the empirical weight. Let me bring this down a little bit. So we're going to take that 56.1 grams and divide it by 14.0 grams. Great. So let's do the math. I already know what the answer should be, but I'm just double checking for you guys. 56.1 divided by 14, and that's 4.007. Okay, so we round it to 4. 4. Multiplication factor is 4. Good. That means we take this thing and multiply the carbon by 4, the 1 carbon by 4, and the 2 hydrogens by 4. So you end up with C4H8. And that is the formula, the molecular formula of the unknown. Those are the steps. You should be okay doing that with your homework, on a test, all of that stuff. Okay, so now we're moving on to another subject. We're going to figure out the formula from combustion information. What do I mean by combustion? Well, if you take an organic compound, something that's got carbons and hydrogens in it, and you burn it in oxygen, you'll always get 2 main products, carbon dioxide and water. All right. So what we're going to do is, based on the 2 products, we're going to figure out what the formula was of the original compound. Okay. They approach this in many different ways. I'm just going to show you one technique, and then you should hopefully be able to figure out other ways of adapting this information. So let's do this here. All right. It's really hard to see. All right, so I've got 0.1647 grams of a hydrocarbon. Okay. And I'm going to burn it in oxygen. They usually burn it in something called a carbon train. And I'm going to tell you that this compound here is just made up of carbons and hydrogens. No oxygen, okay? All right. When you burn it, and again, this, you may remember this from intro chem, anytime you're burning, like I said, anytime you're burning a hydrocarbon, you get 2 products, carbon dioxide and water. So when you burn it, you collect all the carbon dioxide and all the water. You end up with 0.9, I can't see my handwriting. Oh, sorry, that's 0.4. Great. 0.431 grams of carbon dioxide, and you get 0.261 grams of water. Okay, so those are the 2 things you end up with. Helps if I... Okay. Guys, I am so sorry. It will help if I actually can read properly and write my numbers properly. So this is 0.4931 grams of carbon dioxide, and this is 0.2691 grams of water. I don't know why I wanted to eliminate the 9 from both of them. Okay, so the question is, what's the formula? What is your, actually they want to know the empirical formula. So they want to know the empirical formula of this thing. All right, so how do I do that? Well, I need to know the amount of carbon in here. Well, all the carbon that was in the hydrocarbon went into the carbon of the carbon dioxide. So if I can figure out how much carbon is in the carbon dioxide, that's the exact same amount of carbon that was in the original hydrocarbon, right? Because this is a closed thing, and all we did was we put the hydrocarbon, put in oxygen, burned it, and collected all the products. And the products were CO2 and water. Okay, so do you remember percent composition? Remember percent carbon? So if I can figure out percent carbon in CO2, use that percent, multiply it by this number, that'll give me the percent carbon. in the CO2, in this CO2. And if I can figure out the percent hydrogen in water and use that percent to multiply by this number, that'll give me the grams of hydrogen. So I'll be able to figure out the grams of carbon in carbon dioxide and the grams of hydrogen in water if I first figure out percent carbon in CO2 and percent hydrogen in H2O. All right, so how do I do? Remember percent? You put 12 divided by 44. Where did I get the 44 from? I just added up the carbon and the two oxygens. So, and then times 100. Okay? 12 divided by 44 times 100, that's 0.13, without multiplying by 100. Did I just forget? Yeah, you don't have to multiply by 100 for this, but you can. Sure, I'm going to multiply by 100. So let me get the calculator. So 12 divided by 44 times 100, and you have 27.27. So 27.27%. All right. So 27.27% of the 0.4931 grams of carbon dioxide is carbon. So I'm going to take this 0.2727 and multiply. So 0.2727 times 0.4931. I found that I have 0.1345, so 0.1345 grams of carbon in this hydrocarbon. All I did was I took the percent carbon in carbon dioxide, used it to multiply by the grams of CO2 that we ended up collecting, and from that I figured out the grams of carbon. Okay. There's a little trick you can do now. If you know your grams of carbon, if you take this minus this, you'll get your grams of hydrogen. Make sense? You could do that. Or you could still go ahead and figure out percent hydrogen in water. You could say 2.02 divided by 18 times 100. So let's go ahead and do it. 2.02 divided by 18 times 100. And you get 11.22%. 22%. So I multiply this by 0.1122 and 0.1122 times 2961, and you end up with, it helps if I can plug in properly. So 0.1122 times 0.2691, and you get 0.030, okay, 19. I hope I'm copying this right. Grams of hydrogen. Just for the heck of it, let's go ahead and add that to the 0.1345. And yeah, you end up with this number over here, 0.1647. So we're good. We have the grams of carbon, we have the grams of hydrogen. All right, what do we do with those two things? These problems, by the way, are very long, so just be patient. You used your percent carbon in carbon dioxide to figure out the grams of carbon in the carbon dioxide that you collected. Use percent hydrogen in water to figure out the grams of hydrogen in the water you collected. Now that you have this and this, now it's a straightforward empirical formula problem. You take this value, multiply it by the molar mass to convert it to moles. This value, multiply it by the molar mass of hydrogen to convert it to moles. Divide by the lowest number of moles, and you will get, so basically, go ahead and do this. I hope I can wrap this up because I don't know. I don't want the video to be overly long, guys, but it might end up being longer than I wanted. So this becomes, again, using molar mass, this becomes 6.804 moles, 6.804 moles. And then this one over here becomes 18 point, what am I doing? I'm getting weird. I don't know why I'm copying these numbers from here. What did I do over here? I have no idea. No, ignore what I just did. Let me get my calculator. I don't know what this problem is that I have written here. These are fine. So I'm going to take 0.1345 divided by 12, and I end up with 0.0112 moles of carbon. Why did I divide it by 12? Because I just used molar mass to convert grams to moles. And then this one divided by 1 is going to be 0.3019 moles of hydrogen. Okay, so I'm going to divide this by the lowest number, which is 0.0112. Divide this by the lowest number, which is 0.0112. So the carbon is 1. Let's see what this is here. 0.3, see, I'm copying stuff wrong. That's really bad. So 0.03019 divided by 0.0112, and you end up with 2.6 something something something. So that something something becomes 2/3. 2 and 2/3. Remember how I told you, you have to know your fractions. So switch your decimals always to fractions. All right, so we can't leave the 3 in the denominator. So this basically 3. This is 8/3. So you can't have a compound that is C1H 8/3, right? You can't do that. So what do we have to do in order to get a proper empirical formula? Multiply both of them by the denominator. So this becomes a 3, this becomes an 8. So your final answer is C3H8. There you go. Okay. Watch it really carefully. I'm sorry if I may have confused you, but honestly, the steps are correct the way I have them, finally, after clearing a whole bunch of things up. Okay, so we will do stoichiometry in the next video.